Select Side A in the menu bar. Side A of the calculator produces floor surface temperature, average water temperature, and floor output. The scroll bar moves the slide to align known factors to find the desired result. As an example, we begin with a space we would like to heat with radiant floors that is 20 feet wide by 30 feet long. We want to maintain an indoor design temperature of 72 degrees Fahrenheit. A heat loss calculation determined that 20 BTUs per hour are required to heat the space at an outdoor design temperature of -20 degrees. Side A of the RadPad calculator can tell us what floor temperature will be needed to maintain 72 degrees. Using the scroll bar below Side A of the RadPad, line up the 20 BTUs per hour under the arrow in the floor output window. Read the surface temperature above the 72-degree room air temperature mark in the surface temperature window. The result is 82 degrees. The average floor surface must be at 82 degrees Fahrenheit to maintain an indoor air temperature of 72 degrees when it is -20 degrees outside. With that information, we can now find the average water temperature required to reach an 82-degree floor surface temperature. For that, we need to determine the thermal resistance of the floor. There are two scrollable tables below the RadPad slide chart that provide typical R values for various floor components. The one on the left has floor coverings, and the one on the right displays floor structures. Using these two charts, the approximate thermal resistance value of each floor component can be determined. In this example, there is a carpet and pad on top of a concrete slab, with embedded tubing spaced every 9 inches. We will address the selection of tube size and spacing on Side B of the RadPad calculator. Once the R value of each component is known, the values are all added together to find the resulting total thermal resistance of the floor. The RadPad slide chart can now be used to find the average water temperature required to maintain the surface of the floor at 82 degrees. Using the scroll bar, line up the 20 BTU mark on the floor output window with the diagonal line representing a 2.2 R value. Read the average water temperature above the 72-degree mark in the room air temperature window. In this example, the result is 115 degrees Fahrenheit. Since the industry standard recommendation for the drop in water temperature from supply to return is 20 degrees, adding 10 degrees to the average water temperature results in 125 degree supply water temperature. The information can be entered into the RadPad worksheet while working with the charts. The worksheet will make some calculations for you as you move through the sizing process, as shown in this example. Temperature difference, floor design loading, total floor R value, and supply water temperature are calculated within the spreadsheet. The RadPad slide chart, scrollable tables, and worksheet make it possible to easily change any value to see how it might impact the system. The value of this feature will become more evident as you learn to use Side B of the RadPad calculator. For systems with more than one zone, a downloadable multi-zone Excel spreadsheet is provided in the instruction menu. This spreadsheet can be used to collect the data for each zone, determine the total system flow and pressure drop, and total tube requirements. Some calculations are automatic. A printable summary page is provided as well. For more information on using Side A of the RadPad, click the Instruction tab in the menu bar on the RadPad website. Tube sizing, spacing, flow and pressure drop is addressed on Side B of the RadPad calculator and is presented in another video.